So in the last part of this lecture, I'm going to briefly talk about this fancy application called style transfer. So we understand how the convolutional neural network or deep learning algorithm can identify objects in the images, but how we transfer the style of some artistic painting into the current images. So it's actually about what does style mean, right? In our mind, when we look into an image from these different types of pictures, we can see, oh, these two images have similar styles because they have similar kind of stroke, color, etc. But how actually you define these concepts in your algorithm? So this is probably you can think about it mathematically. What does style mean in numbers, right? I have a bunch of numbers and another bunch of numbers. So what does that mean? Like, okay, these two numbers have similar style. And the answer can be summarized in this so-called style transfer. So on the one side, we have definitely the input of so-called content image. So we want the content of the image to be close in terms of, okay, if we have input of the content image as a car, definitely the output should be very close to a car. But on the other side, you want the style image. You have the style image and you want the style to be similar. So for the content difference, it's very easy to define, right? So if I have image as a content as a car, you just combine the difference between a car and not a car, the output of the image. You want the difference between them very close. So this is just a least square loss. You just want the pixels to be close to each other. So this is content loss, which we understand perfectly. But what do we mean by the style are similar, right? So we have two images. What does that mean that two images have similar styles? So the style information is measured by the amount of correlation present in different maps. So we use the concept in statistics called correlation. And so if we have a Starry Night from Van Gogh and we have another image very close to the style of the Van Gogh of the Starry Night, so we are not comparing the exact formulation of these two kinds of images, but the correlation, right? We want the pixels and the organizing of the pixels are highly correlated such that they have similar styles. So this is how we define a style in mathematics, and we just want to enforce image close in content by comparing the loss of these two images, but also want the correlation between two images to be close. And then we go back to this style transfer. So we want the output of the image, the generated image, to be close in content, comparing the difference in pixels, and also close in style, comparing the correlation between two images. And then we can have the effect just like this style transfer. Okay, so I just want to use the last minute to give you a very interesting and most recent applications about all these results, which is called DALL-E. So the DALL-E, what is DALL-E doing is if you input a sentence like here, a corgi playing a flame through a triumphant, and then you can see that the algorithm will find some corgi and find the triumphant, but actually we need to organize them together, right? Using all these ideas we have found in the previous applications. And so here are some results. So first, what you are going to do is just input some sentence, right? So here it's like the Kermit frog painted by Munch. And so probably have seen the original Munch picture in the style. So it can actually output some interesting images just like this. This is like, you can imagine combine the style correlation and the subject together, right? The algorithm not only need to identify subjects, but also need to put the relationships in it. And sometimes it will output some also interesting tasks and results. Probably you can think about it. How would you like generate the image from your human being brain, and let's compare it with like how the algorithm gives you. So this input is the head of broccoli complaining about the weather, which is a kind of ridiculous image. And you can first picture in your mind, how would you imagine that kind of picture it is? And then here it is. And you can see that it's quite interesting. So the computer just generated by itself. I'm not sure how different it is in your mind, but we believe that it's actually a reasonable the output, right? So the next one, a Spider-Man from ancient Rome. Probably you can think about, imagine how would you picture it, a Spider-Man from ancient Rome, which is also kind of interesting, right? So it never happened in realistic life. No one has pictured that before, but the algorithm will give you this output, which I'm not sure if it's how you imagined in your mind, but we think it actually makes sense, right? It's the style of the ancient Rome sculpture and in Spider-Man. So, and then the next one, the still of Homer Simpson in The Godfather. So Simpson in The Godfather, what will happen, right? So it's also kind of ridiculous in combination. But here it is. No one has pictured it before, but the algorithm is very creative, right? So you can see it's not some great artists combined together, but we can see some creativity behind it. So here I just post this the link of this algorithm, which is not the perfect version of it, but some like toy version of it. You can try to play with it, and so it's called DALL-E Mini. You can just actually Google it and play with by yourself. You can input some interesting, like for example, Pikachu graduated from Harvard. I just let it run, and after, so because like I said, the ImageNet or this deep learning algorithm involves like a great amount of computation. So this so-called DALL-E Mini is like an easier or light version of the algorithm. And it may not give you a very perfect output, but it will, because of the computation is very heavy if you want to get some fancier result like what I showed you. But it will give you some faster, but still some like similar results. So I have passed some time, but I think like during your break, you can play with these results and see how it outputs. And also I recommend you to take a look about, for example, this is the Instagram account of DALL-E. It gives you more example about some input and output, which is quite interesting. There are some heavier version of the DALL-E, so you can visit their official account, DALL-E 2, and they also give you some like examples. For example, an astronaut riding a horse in different style in Andy Warhol, pencil drawing of vertex, and a bowl of soup in another, which looked like a monster in a knitted out of wool. So it's very interesting to play with it, but sometimes it's very high demand of computing, so they just show some examples. But this network, oh wait, why it's sorry, I think somehow. Yeah, this is like my previous test. We can probably think, so I just input Pikachu in Zoom meeting. Actually, I want to test but anyway, so you can test whatever you want to test and play with it. And meanwhile, I want you to think about, okay, from different kind of inputs, what can you learn from the algorithm, right? So why this algorithm can, how this algorithm understand human being, right? Just treat the algorithm as some like a real person, right? So do you think like some kind of personality or habits from these algorithms? And yeah, just like that. So I think that's all I like to talk about today. So next time, I will give like some other more specific things about how the computer understand the relationships between all these objects in these images, and more about that. So thank you very much. And any question?